Here is question 6 from 2015. We are given a function, an equation y, and they give us the derivative of that function. And it says write the equation of the tangent. So we got the tangent line, and they give us a point. So what else do we need besides a point? We need the slope, which is right here. So all we have to do is plug in our numbers where they go. So y is 1. And we plug in x. I'm sorry, y is -1. No, x is -1. We should make that +1. And we solve this, and 3 times 1 is 3 plus 1 is 1/4. So the equation of the tangent line is right here, and there's part A done for you. Part B says find the coordinates of all points. So we need points in which the tangent line has a vertical slope. That vertical slopes mean undefined. And undefined comes where the denominator is 0. So we're looking at this denominator up here in my dy dx. We want that denominator to be 0. So we need to find where 3x squared minus x equals 0. So if I add x over to the other side, that means x has to equal 3y squared wherever the slope is undefined. So then I come up here and I use this equation, and I'm going to plug 3y squared in for my x. Then I can solve that, and that will be my y values. So I'm going to get y cubed minus 3y cubed equals 2. -2y cubed equals 2. Divide by -2, so y cubed equals -1. Cube root -1, which gives me y equals -1. So my y value is -1. I'm going to stick that -1 up here for this y. And -1 squared is 1. And 3 times 1 is 3. So there's my answer. So at the point, I'm going to erase my work so I got room to work right. At the point 3, 1, the slope of the tangent line, I shouldn't say the slope, my bad, that would be wrong. I'm not allowed to say the slope. You should just say the tangent line is vertical. And part B is done. The last part says find the second derivative, and then we are going to evaluate it at the same point that we had up here, where x is -1 and y is 1. So to get the second derivative, I'm going to have to do quotient rule. So quotient rule says the bottom times the derivative of the top, so the derivative of y is dy dx, minus the top times the derivative of the bottom, so 2 times 3 is 6y, and again we're doing derivative of y with respect to x, so I need a dy dx here, minus 1, and then that's all over the bottom squared. So now I'm going to take that x and those y's and plug them in. Normally I would have had to stuck this thing back in for these dy dx's, but if you recall, problem 1 we found on problem 1 that that was 1/4. Now, the way we're supposed to tell them what we're doing, as we write down our second derivative of y with respect to x, there's been a 2 there. And then we tell them, hey, we're going to plug in the point -1, 1. So that's going to equal 3 times 1 squared plus 1. And again, from number 1, we got this slope was 1/4 right there. I'm plugging this stuff in to the equation above there. And then minus my y is 1. And then 6 times 1. And again, this dy dx is 1/4 from problem 1. You don't have to work it all out again. And that's going to be over 3 times 1 squared plus 1. That whole thing squared. Now, you do not have to solve that. You're done. That's the answer. That will give you both points. Or, sorry, that's worth 3 points on this one. If you do solve this, you end up simplifying to 1/32, but you don't have to. So that's the end of problem 6.